Now that we have some history on how we've studied intelligence in the past, we're going to move on to trying to answer that question, what is intelligence? When psychologists have tried to study intelligence, they tend to follow one of two broad approaches. The first is the psychometric approach, and the second is the cognitive process approach. We're going to start with the psychometric approach. Now, psychometrics is the study of psychological tests. So when we're looking at the psychometric approach to understanding intelligence, this approach is trying to identify and measure the abilities that underlie individual differences in performance. Basically saying, can we use our psychological tests to try and map out the structure of how our intelligence works? Can we figure out what's going on underneath the surface that's driving differences in performance? Can we figure out what mechanisms might be involved that make some people appear more intelligent or less intelligent? We're going to come back to the cognitive approach later on in the chapter, so we'll leave that there for now. A lot of the psychometric approach is going to involve trying to figure out different mental abilities, different categories that we can divide things into. So how many mental abilities do humans have? How many ways can we divide up our intelligence? Which ones are related to each other? How many are there? In order to answer these kinds of questions, you have to set up a series of tests. Specifically, you'd have to be able to deliver a bunch of diverse measures of mental abilities. So you'd want to do intelligence tests that look at verbal abilities. You'd want to have tasks that evaluate your performance on problem solving. Whatever you can think of that might be related to intelligence, you'd want to deliver tests that test that. Once you've delivered as many tests as you can think of, you'd want to look at the results of those tests and see if any of those results correlate with one another. Basically, you're asking, are there any tests that people who score high on test 1 always score high on test 2, while other people tend not to score high on it? Or is there any test that people who score low on it also score low on another test? If you have a correlation between some of these tests, you might conclude that the two tests are looking at the same type of thing. So if we can find a mathematical cluster, these strong correlations between the output of two different tests, then we can start concluding that these tests probably reflect the same underlying mental skill. Maybe they're both looking at your verbal ability. So if you are good at verbal reasoning, then you're going to score high on both tests 2 and 3. And then you can start looking at these clusters of correlated tests. And so say that we have a lot of tests that correlate highly together, we'd say that they're all related to the same mental ability, and any tests that don't correlate with that group, with that cluster, are going to be testing some other mental ability. Maybe instead of testing verbal skills, they're testing spatial sense. Now you might imagine, just by talking about running as many tests as you can and trying to find correlations between them, you can run into this issue where very quickly it becomes difficult to figure out which tests are correlating with which other tests. The more tests you're looking at, the harder it is to evaluate these factors, these test correlations by yourself. And that leads us to a statistical technique called factor analysis. And factor analysis can be used to reduce large number of measures into a small number of clusters. Each of these clusters would be called a factor. So instead of looking at 10 scores that all correlate together, you could represent that highly correlated cluster with a single factor that we can assume that one factor might be related to one mental ability or one type of mental ability. And so just like we said before with the clusters, each cluster that makes up a factor should be containing variables that correlate highly with each other, but don't correlate highly with other variables that would be in other clusters. So we can consider them separate from each other. And a factor is going to allow us to infer that the underlying characteristic that's going to account for that link, that correlation between all of those variables in the cluster, maybe it's a particular mental ability. So we're making some assumptions here. Now, that's all well and good to try and visualize, but let's actually get a visual here. So this table from our textbook is going to show us the correlation coefficients for 6 different tests. So this is what it looks like if you only looked at 6 tests. And so the way that we can read this chart is we have our tests 1 through 6 across both axes. And so our correlation coefficient that's given along the diagonal here is 1. And the reason why it's 1 on the diagonal is because test 1 is going to have a perfect correlation with itself. So for every 1 increase in your score on test 1, you're still going to see a 1 increase in your score for test 1. So that's why there's a bunch of 1s across the diagonal. We can basically ignore those because it's not giving us useful information. But if we move over and we look at the correlation here, the correlation between test 1 and test 2, this is a very high correlation. So 0.8 is a very strong positive correlation. And next to that, we have a strong correlation between test 1 and test 3, or between test 3 and test 2. So here we're seeing a relationship between tests 1, 2, and 3 where they all relate to each other. So we see this cluster of correlations here. So this might be one factor. This might be one mental ability that's captured by these 3 different tests. And even though these are all highly correlated, we can see sort of lower values over here. So test 1 doesn't correlate strongly with tests 4, 5, or 6. So these are still positive correlations. This is an R of 4.6, but it's not a very strong correlation. We do see a second cluster down here with our yellow triangle, and that's showing a relationship between test 5 and test 4, and test 4 and test 6, and test 5 and test 6. So 1, 2, and 3 form one cluster, and 4, 5, and 6 form another cluster. So here we're looking at 2 factors that could be considered within factor analysis. Now, if this is as complicated as it gets with only 6 tests, imagine what would happen if you were running 100 tests. What about 1,000 tests? So this is why we use statistical methods to try and do this without requiring a visual inspection by the researcher. The earliest psychometric argument for intelligence was proposed by Charles Spearman in 1923. He was a British psychologist who had observed that children taking different subjects in school tended to do well overall on most subjects, but their performance in each individual subject wasn't always perfectly correlated. So for example, a child might be not very good at math, but would do well in English and history and other courses like that. When looking at some of the Stanford Binet intelligence test questions, he also found that there was general correlation between different types of questions. Things that were testing vocabulary or arithmetic, different kinds of reasoning, there tended to be an overall slightly positive correlation that he decided must be an equivalent of general intelligence. He termed this general intelligence a G factor, and proposed that we had a baseline general intelligence that could allow us to perform general tasks, and our performance on any given task was modified by both our general intelligence and our specific ability that related to that particular task. So for example, your performance in a math class would depend on your general intelligence and your specific ability to learn mathematics. This idea of general intelligence has carried through to today, where quite a few researchers still believe that there is some general measure of intelligence, where some people are overall more intelligent than others. And in fact, this general measure of intelligence seems to strongly correlate with performance in both areas of academics and in jobs. So even though this theory was proposed quite a long time ago, it still seems relevant today. Our next discussion is going to focus on Thurstone's idea of primary abilities. And Thurstone basically came up with an idea that stood in counterpoint to Spearman. So where Spearman was impressed that there was at least some positive correlation between all these different measures of intelligence, Thurstone decided to focus on the fact that there were differences between those correlations. So he focused on the fact that the correlations weren't perfect. So Spearman was impressed that there was a positive correlation at all, and Thurstone was more impressed that it wasn't a perfect correlation, and he took that to mean that there must be specific abilities that affected all different aspects of our intelligence. So Thurstone wasn't believing that there was just a general intelligence and that explained everything. He focused on that idea of specific mental abilities. And so he broke down our intelligence, our mental abilities, into 7 primary mental abilities. And those are listed here on the next slide. So the first of these was space, where you have reasoning about visual scenes, verbal comprehension, where you could understand verbal statements, word fluency, number facility, perceptual speed, rote memory, and reasoning. All of these, he argued, made up our mental abilities. And so unlike Spearman's argument that if you were good in mathematics, it was because you had that general intelligence and a specific mathematical ability, Thurstone would argue that your mathematical performance was based mostly on your number facility, your ability to deal with numbers. He would argue that this specific mental ability, this primary mental ability, was the driving factor behind your performance in mathematics. It wasn't down to a general score of intelligence. And though this perspective on mental abilities isn't ideal or perfect, it still has some appeal, especially for educators who find it very appealing to look at things like your performance in a mathematics course relates to your number facility. Your performance in an English course would be related to your word fluency or your verbal comprehension. And so they could start using your scores for these 7 different types of mental abilities and use that to determine how to best teach a particular child. So this has practical applications, which made it a very appealing theory to look at. Our next theory of intelligence looks at crystallized and fluid intelligence. And so in this case, 2 researchers, Carroll and Horn, decided to break down Spearman's general intelligence idea. And so they broke general intelligence down into crystallized intelligence and fluid intelligence. So in this theory, these 2 subtypes of generalized intelligence would be related to one another, but not completely and perfectly correlated. So they said they would have a correlation of about 0.5. So positively correlated, but not perfectly correlated. For the first of these two subcategories, we can look at crystallized intelligence. And this is basically how you can apply previously learned knowledge to current problems. Things like vocabulary and information tests would be a good measure of crystallized intelligence. And this crystallized intelligence would relate back to people who were experts. So if you have expertise, you have this pre-existing knowledge that helps you solve new problems and handle tasks that are related to things that you've seen in the past. So crystallized intelligence is going to be dependent on things that you've learned previously and your practice with applying those factors. In contrast, our fluid intelligence is all about solving new problems, dealing with novel situations without using any previous knowledge. So fluid intelligence would involve inductive reasoning and creative problem-solving skills. Basically, you have to come up with a new solution without relying on anything else that you might have known. So if we start considering things that are different between these two types of intelligence, we can consider what type of memory helps with either of these forms of intelligence. So with crystallized intelligence relying on previous knowledge, long-term memory is going to be the most important type of memory for that kind of intelligence. Whereas fluid intelligence deals with finding new and creative solutions, so your working memory is going to be very important for fluid intelligence. And similar to the idea of going from inexperienced to being an expert in a particular area, as we get older, we'll move from relying on fluid intelligence to more crystallized intelligence as we gain experience and build up knowledge from interacting with things in the world. And this might be beneficial because crystallized intelligence relies on long-term memory, and our long-term memory tends to last very well as we age. As long as you don't run into things like dementia, even into pretty advanced years, you can have a fully functioning long-term memory. In contrast, as we get older, our working memory tends to perform less well. So our ability to think in novel ways and handle new solutions using that fluid intelligence would decline. So it works out well that we rely more on crystallized intelligence as we get older with how things work out. For our next theory of intelligence, we're going to look at Carroll's Three-Stratum model. This is a more modern approach where basically John B. Carroll took a look at the field of studying intelligence and realized that there was basically a century of different tests of intelligence that had been conducted. And so he decided to take a step back, look at all of the research that had been conducted, and try and synthesize all of that research down into a more cohesive model. So he decided to use factor analysis to look at 460 different data sets. And by condensing all of this data, by starting to pull out factors from all of the data that was available, he ended up finding an integrative model of intelligence. It basically combined the elements of Spearman's, Thurstone's, and even Cattle-Horn's models. So he took the three models that we've already talked about and condensed them into a single model. He called this the Three-Stratum model, or the Three-Stratum theory of cognitive abilities. And so his three strata, his three levels for these cognitive abilities were general, broad, and narrow. Now this is one of those models where I feel like the visual is a lot more helpful than the words describing the visual. So we'll switch to the next page to look at this here. And so here we'll start at the top looking at our general intelligence with the third stratum. This is that G factor you originally started talking about. And our second stratum, our broad intelligence, on this second level here, is arranged from the most closely related or the most strongly influenced by G, our G factor, with fluid intelligence. And as we move from left to right, these arrows get longer, meaning that these different categories of intelligence are less and less closely related, less and less correlated to our general intelligence, or G factor. So here we could say that fluid intelligence is most closely related to general intelligence, and processing speed is least closely related to general intelligence. And the fact that we have fluid intelligence and then crystallized intelligence as the two factors that are most closely related to general intelligence tells us just how important those cattle horn factors are, because they relate so closely to our theory of general intelligence. They're so strongly correlated here with that G factor. And then we can look at the bottom tier, our first stratum, our narrow intellectual abilities. And these are going to be specific cognitive, perceptual, and speed tasks that help us sort of build up the more broad abilities above. And though we don't break them down here, most researchers will agree that there's 70 or more different narrow or specific factors that could fall into this green box at the bottom. So we're going from very general to very specific as we pass through these levels. And though these different factors, these three different levels, originally came from a factor analysis, Carroll is fairly confident that what was identified in the factor analysis should correspond to actual processes that are going on in the brain. So there should be something related to fluid intelligence that could be found in our brain. There should be part of how we think that ties to broad retrieval ability, because the idea here is that if the things that make up our broad retrieval ability are all correlating strongly with each other, then it should be some kind of equivalent to those mental abilities, kind of carrying forward all the theories that have got us to this point. Now, at the very beginning of this section, we had talked about the two different approaches to studying intellect. We had talked about our psychometric approach, where you're trying to map all of the structures that make up our intellectual abilities. But now we're going to get into the second point, the cognitive process approaches. And for these, we're going to be looking at the specific thought processes that underlie our mental competencies. So what's going on underneath? What thought processes are involved underneath all of those structures and divisions that we talked about with our psychometric approach? We can explore the information processing and cognitive processes that are involved in our intelligence. We're going to start with Sternberg's Triarchic Theory of Intelligence. Now, this theory divides the cognitive processes that underlie intelligence into three specific components. We have our meta components, our performance components, and knowledge acquisition components. I'm going to talk about all three of these in just a moment when we get to a visual for them. First, let's talk about Sternberg himself. He was a strong proponent of the cognitive processes approach to intelligence. He looked at the idea that those psychometric theories of intelligence could explain how people differed from one another in terms of intelligence, but they didn't explain why. And so he wanted to understand what was going on cognitively. Why was this difference happening? And so he designed this theory to specifically look at both the psychological processes that are involved in intelligent behavior and to try and evaluate the diverse forms that intelligence can take. So it's kind of a two-part theory here. Which brings us to the diagram. We're going to start with our three components here at the bottom. Our components, performance components, and knowledge acquisition components. Meta components are more high-order components that allow us to plan and regulate our task behavior. This category would include things like problem solving, where we identify problems, propose different solutions, and evaluate the effectiveness of those solutions. Thornburg believes that these meta-components would be involved in fluid intelligence. The performance components are going to be the components that actually allow you to perform the task at hand. Things like perceptual processing, retrieving the memories that you need to approach this task, and schemas for long-term, or schemas from your long-term in order to generate a procedure. So this is how you're actually executing the strategies that were planned out using the meta components. And then our last type of components are the knowledge acquisition components. And these components allow us to actually learn from our experience. We can encode and store information as we encounter new scenarios. As we've solved problems, we can store what we learn from solving that problem away for use in the future. And this storage of knowledge would be what's involved in crystallized intelligence, which connects us again back to that Carroll-Horn theory of fluid and crystallized intelligence. So they're all connected here. At the top of this graphic here, we have the three types of intelligence that Sternberg thought would be involved in our intelligence. So we have analytical, practical, and creative intelligence. He argued that analytical intelligence would be sort of the traditional kind of intelligence, with problem-solving skills that could be measured by traditional tests of intelligence. Our practical intelligence would refer to skills needed to cope with everyday demands and to manage yourself and others practically. And then creative intelligence would be our mental skills that we would need to adapt to novel problems. How do we deal with new situations? And so these three levels, these three types of intelligence would all work together to allow us to survive in our environment. Now for the next part, we're going to take a step back from all of these interrelated and interconnected ideas of intelligence, and we're actually going to look at a broader conception of intelligence. Specifically, we're going to look at Gardner's theory of multiple intelligence. The idea that there's more than just one type of intelligence. Now this theory falls under that broader conception of intelligence because it's not just looking at intelligence as an idea of mental competence. It's actually looking at a much larger scope than just our mental capabilities. And this kind of scope should become a little bit more clear as we actually look at his 8 relatively independent intelligences that were originally proposed. But we should make note that there has been some speculation about a 9th possible intelligence, this existential intelligence, sort of knowledge of your own finite existence, but that one is still quite up for debate. But let's look at the 8 independent intelligences that make up the core of Gardner's theory. And so these are going to be listed here. We have linguistic intelligence, logical, mathematical intelligence, physiospatial, musical, bodily/kinesthetic intelligence, interpersonal, intrapersonal, and naturalistic. And so if we look at each of these individually, so linguistic intelligence would be the ability to use language effectively. So writers would have a high linguistic intelligence. This logical and mathematical intelligence would have good reasoning in terms of mathematics and logical abilities. Visuospatial, you'd be able to solve spatial problems or succeed in some kind of field that relies on visuospatial abilities. Things like architecture. You can think in those 3 dimensions and reason in that 3-dimensional space. Music relates to pitch and rhythm, the ability to understand and produce music. Bodily kinesthetic intelligence relates to your control over body movements. So can you skillfully manipulate objects? Are you dexterous? So an athlete or a highly skilled dancer, a surgeon, those people would all have very high bodily kinesthetic intelligence. Interpersonal is that you can understand and relate well to others, and intrapersonal is that you can understand yourself. And for the last, naturalistic, you can detect and understand phenomena in the natural world. So you relate well to your environment, to the natural world that surrounds you. So these are all a lot more in depth than simple mental performance. This is beyond just your mental capacity or mental competence. This is how you interact with the world around you. And that's why this is a more broad category or concept of intelligence. And though the first 3 items on the list here might easily fall into being tested by existing intelligence tests or IQ tests or tests of performance, it's very difficult to measure the remaining ones. There isn't necessarily a standardized test of musical intelligence or interpersonal intelligence. So these areas are a lot harder to study than the traditional idea of intelligence that we've talked about throughout this chapter so far. Another broader conception of intelligence is the idea of emotional intelligence. This was proposed by Mayer and Salovey, who stated that our emotional intelligence is going to involve our ability to read others' emotions accurately. Can you tell what other people are feeling? Can you know if a friend of yours is sad, or can you identify a stranger who's frustrated? Can you respond to them appropriately? Can you adjust your own behavior in response to others' emotions? Can you motivate yourself? Can you be aware of your own emotions? Can you regulate and control your own emotional responses? So all of these relate to your emotional intelligence. And so we can look at the Mayer, Salovey, Caruso, they tacked in another name, emotional intelligence test, which you can shorten down to this. But their test of intelligence would include specific tasks that allows you to measure each of the 4 branches of emotional intelligence that they proposed. So the first branch of emotional intelligence is perceiving emotions. And so we can evaluate your ability to perceive emotions by checking the accuracy in judging emotional expressions in facial photographs. So if you're shown a bunch of pictures of people, can you tell which ones are happy, sad, angry, fearful? You also look at their accuracy in judging the emotional tones conveyed by different landscapes and designs. If you look at art, can you tell that this piece feels sad, or that this design is a happy design? We can also look at the other 3 branches. So that's just the perceiving emotions. We can look at the second branch, where you use emotions to facilitate thought. Tasks to evaluate that ability would be seeing if people know what kind of emotion would best enhance a particular type of thinking. So what emotion should you hold on to if you're planning a birthday party? What emotion should you hold on to if you are helping console someone who has lost a loved one? Our third branch is understanding emotion. How well do people know which emotions combine to create certain nuanced feelings? Or can they identify when certain emotions change from one type to another? And for our fourth branch, we have managing emotions, where you would evaluate the participant's ability to change their own emotional state to facilitate some kind of task, say working in a group. So there's very precise ways of measuring all of these emotional components. But as you can imagine, it might be difficult to score or accurately judge these different components. So most of the time you need an expert scorer to give you a reliable measure here. It's also important to note that when judging people's emotional intelligence, it's important that these tasks evaluate how well they perform and don't just ask individuals to evaluate their own emotional intelligence. Humans aren't necessarily the most reliable sources of information because they tend to under or overestimate their own emotional intelligence. So you're much better using scores where you're not relying on the participant to tell you how they're doing, but rather where you can observe them using these different types of emotional intelligence. Now, of course, some people don't love the idea of emotional intelligence. They think that this is too far of a stretch from the concept of intelligence, and they would prefer that the term emotional competence is used instead. But those who support this idea of emotional intelligence can point out quite a few adaptive advantages for having a high emotional intelligence, to be good at managing emotions. The first of these adaptations would be the existence of stronger emotional bonds. If you're a supervisor with high emotional intelligence, maybe you can create a feeling of family, a feeling of loyalty within your employees, which can then lead to things like greater success. If you are successful at making people believe in your goals and join in on what you're doing, that can lead to success. And this doesn't have to just be success in employment. This can also be success in marriage or child rearing, all sorts of aspects. And there's also the obvious of being able to control your own emotions. You can have less intense depression. You can reduce your own anger or anxiety. And you may even be able to help control your impulsive behavior. You're able to be aware of and in turn control your own emotions. So having adaptive advantages with these emotions might explain why it seems to be a universal trait. Though not everyone agrees on the idea of emotional intelligence. And considering this is a newer model of intelligence, proposed quite a bit more recently, I'm sure there's a lot more debate and a lot more evolution in this area to come in the future.